Hello, everyone, and welcome to the GoodData Qdrant Fireside Chat. I'm your host, Stepan, and let me introduce you to our today's speakers, Kacper from Qdrant and Jacek from GoodData. Welcome, guys. Kacper, could you please briefly introduce yourself and Qdrant to those who might not know you and your company?
Of course, thank you. First of all, thanks for the invitation. My name is Kacper Łukawski. I'm based in Poland, and I represent Qdrant. I'm a senior developer advocate here in the DevRel team. And Qdrant is a vector database. However, we prefer a vector search engine. And the main purpose of Qdrant right now is to build scalable semantic search applications. So we provide this semantic search layer in a very effective way.
All right, thank you very much. Jacek, could you please tell us something about yourself?
Yeah, so my official name is Jan Soubusta, but everyone calls me Jacek. So officially, I am field CTO in GoodData. No one knows what does it mean. So I am like part-time engineer slash architect, part-time developer advocate, but like usually I communicate with the technical audience, which is exactly this case.
Awesome. Thank you very much, Jacek. And to kick off the conversation, I actually have a question for you, Kacper. Lately, I've seen multiple job offerings which require Qdrant or some other vector search engines as the prerequisite. Could you please explain why does the market these specialized vector stores?
Of course, this is a pretty common question because there are some other tools that incorporated vector search as just one of the features. However, we believe that vector search requires some specialized data structures, and if you just add it as another feature of an existing relational database or a different tool, then you can't really scale it properly because you still need to maintain the other features you have. And that's actually a case. Some of the existing relational databases claim to have vector search support, however, they struggle with high loads of data. And I believe vector search requires specialized tools mainly because of that, and also because it comes with a variety of problems related to doing that effectively. In a nutshell, vector search, semantic search is all about comparing the distances of high dimensional vectors. These vectors usually have around a few hundreds up to a few thousand dimensions. And since you never know the vector embedding of the queries you're going to receive, you can't really pre-compute these distances ahead and then use this cache to serve the results effectively. So that's why vector search engines such as Qdrant use specialized data structures such as HNSW, which is a multi-layer hierarchical graph data structure that performs approximate nearest neighbor search that actually solves vector search. And vector search is not only about dense vector embeddings, but also about sparse embeddings, which are becoming more and more popular, metadata filtering, and many other problems. So actually, search is an important problem that requires separate means. And that's also making vector databases so important in the modern data landscape.
Perfect. So maybe I will take it over now. And so you quite nicely explain like why it is actually a good idea to do not use like a relational database claiming it supports vectors. But what are the key differentiators of Qdrant when we compare it with other specialized vector databases?
Oh, definitely there's like a huge market. So definitely I would divide this existing vector databases into two main categories. So first of all, there are open source tools such as Qdrant, Weaviate, Milvus, um, and some others. Like actually there are so many players, but I would say these ones are the most important ones. Obviously, there are tools like Elasticsearch and OpenSearch adding vector search capabilities. And there are also some cloud-only vector databases such as, for example, Pinecone. And obviously, that's the main difference like between these two categories, that some of them might be self-hosted. For example, you can set up development environment easily, and for some others, you just need to use the cloud offering, and that might be a pretty tough limitation for many businesses. If you, let's say, need to self-host your data and you can't really transfer it to any cloud provider, then you can't really choose any of these proprietary tools. And there are also other differences regarding how we built the search engine. Qdrant decided to be a very small yet effective system that does one thing well. And we do not integrate models directly into the core of the system. You can't really spin up a model inside of a database. Actually, that doesn't even make much sense to me, because obviously running specialized embedding models usually require having some GPU instances on your machines. And vector search engines rarely use them, so there is no point in making your infrastructure even more expensive than it could be, because you can have separate instances where you deploy your models and separate instances for running vector search effectively. So I would say those are the main differences. Also, when it comes to functionalities, I think this is pretty unique. I think that none of the other vector databases has introduced that. But a pretty key functionality is that you rarely just want to perform a vector search alone. Typically, you also have some additional constraints, like for example, you need to implement multi-tenancy, and in that case, you don't want to search over points that do not belong to other customers that you are just serving. So in that case, Qdrant has a pretty unique approach of running this filtering together with vector search in a single pass, which is quite effective, and it actually mitigates the problems of pre and post filtering. And also, if you just look at any benchmarks, you will clearly see that we are just quite efficient, just because we focus solely on effective vector search with any optimizations that happen to occur in that space. So I would say this is the main differentiator of Qdrant versus the other search engines.
Yeah, I can confirm what you just said. That's exactly why we actually decided to go with Qdrant, because how it's efficient. But we also decided to go with Qdrant because actually, like how easy it is to deploy it and maintain it on premise. So can you elaborate a little bit more on that and like compare it with your competitors?
Of course. So basically, Qdrant is a really lightweight tool. I don't remember the exact numbers, but our main Docker image is like 50 or 60 megabytes. So it's not like a huge binary that we provide, but this is really lightweight, and people were able to run it even on Raspberry Pi. I do not recommend doing that, but obviously there will be always nerds that will try it. I also know there are some tools that require you to run like a whole infrastructure. So you need to have like multiple containers running to support vector search, even though you are not really dealing with high scale data. So this is a main difference. We also provide a Kubernetes Helm chart, so you can run Qdrant within your Kubernetes environment. And more recently, we've also created a hybrid cloud version of cloud, where you get all the benefits of the managed cloud, like programmatical access to your clusters, a pretty nice UI that allows you to spin new clusters, scale them up and down. And this all can run on your own infrastructure. It works in a bring your own Kubernetes cluster manner. So if you have an existing environment, you don't want to expose your data to any cloud provider, you can just use our hybrid cloud and run the same Qdrant instance with this additional benefits of managed cloud inside your premises.
Yeah, I actually, because I'm curious engineer, so I have one question which relates to Qdrant, but not like directly. I noticed that Qdrant is actually implemented in Rust language. So I suppose you have many very skilled Rust developers in your company. So can you just briefly comment on how how complex it is to develop something so complex like vector database in this language compared to other languages, and why you decided to go with Rust actually.
Yeah, definitely. I'm not a Rust developer. I'm also not a member of the core team, so I can't really tell how easy it is. I bet it's not that easy. Like I had some looks at our code base, and definitely I could easily navigate in it because I have some development experience. However, our core team is not that big. I mean, it's probably around 10 people. But yeah, definitely great Rust developers, and Rust comes with some benefits like it's a memory safe language, so it's really important when you implement a database, so you don't have like memory leaks in the system, because that would eventually lead to some failures of the system that was supposed to be running without any downtime. And yeah, that was a great choice. Like since the very beginning, we've chosen Rust to support our core offering. And yeah, definitely that was a great choice just because this is a low level language. So definitely better suited for writing this kind of applications than, let's say, Java or anything based on
I
this
agree.
ecosystem.
Yeah. Okay, so that's the current state, and now let's look into the future. I'm really interested in what is on your roadmap actually, because we already utilize Quadrant, so what we can look for in the future.
Yeah, so I would definitely like to start with our most recent release, because that has been released less than a week ago, and it's 1.15. That brings a lot of improvements, like additional features in terms of text filtering. So we finally support multi-language tokenizers. We also have released score boosting in the previous one. So we're actually going into a direction of supporting just more and more modes of vector search, more and more filtering capabilities, because that's what our users request. And since GoodData is also one of our users, feel free to just submit a request. That's actually what I did a couple of weeks ago, because I thought that would be nice to have maximal marginal relevance, which is a technique that is used for diversity, improving the diversity of the search results, which is especially important in retrieval augmented generation when you have lots of near duplicates. And it has been also released in the recent version. And obviously we'll be also trying to support our users who use BM25, because BM25 is still a strong baseline for text search, text lexical search. And that's why we are also going to implement BM25 directly into the core. So you don't really need to send sparse vector representations, because that's how you can do it right now. But you will be able to just send your text, and that will be all handled by Qdrant. That was a common request. So people want to have BM25 or want to build hybrid search, so dense plus BM25, for example. And what's more, we also have a pretty nasty feature. It's only available in US regions of our managed cloud so far, but that's definitely gonna be available in all the regions pretty soon, which is server-side embedding inference. We just realized many of our users don't really want to set up their own infrastructure for creating the vectors. And we also didn't want to introduce it directly to the core, because that would lead us to a place where we would need to support these models directly somehow, and probably run that on very expensive machines. However, in cloud, we have a separate inference service that you can activate on your clusters. So you can just send textual data, URLs of the images you want to vectorize, and then this will be handled automatically. So you don't really need to set up your own inference infrastructure, what makes sense in many cases. We also want to include some more features into our text filtering. This is still like majority of use cases where people just want to search over text, and it usually makes sense to have like logical operators implemented. So that's gonna be also supported. But Qdrant also focuses a lot about optimizations. So we were the first, or one of the first vector databases to introduce binary quantization, for example. And since then, we are also trying to incorporate more and more optimizations, so we can actually fit more vectors into the same infrastructure, and that's also in the roadmap. So like definitely you are gonna see some improvements in terms of performance in the upcoming versions of Qdrant. And yeah, feel free, if not only GoodData, but anyone who is listening to this episode, feel free to just submit a feature request if you see there is something missing in Qdrant. We're definitely open to introduce such features relatively soon, because we are really agile in that way that we don't really need to plan that ahead for a couple of months. But if there is something interesting, we can do it right away in the next release probably.
Perfect, perfect. Our infrastructure team actually will be really happy because they are always looking for where they can actually reduce cost. So that's actually why we decided to go with Qdrant, because not only engineering but actually infra team was very happy as well. My last question, just briefly, a little bit like maybe philosophical question. So what what will be the role? What do you think will be the role of vector stores in the future, in far future, where like everyone predicts there will be fleets of AI agents and a lot of AI automation, but still under the hood there will be some semantic search, I am pretty sure. So what do you think will be the role of Qdrant in this future stack? Just
Yeah,
briefly.
so definitely like this vector databases market is pretty crazy. There are just so many competitors. I believe Qdrant is still the best one, and definitely that's where I see us still in upcoming years, because we just focus on doing one thing well, as I said before, and this is all about search using vectors, different kinds of vectors. So yeah, like vector databases are not going anywhere. Still, if you even build the most fancy agent that combines multiple tools, you need to have some sort of retrieval mechanism, so you can bring your company data, your personal data, because none of the existing LLMs was ever trained on your data unless you had like a huge data leak from the organization, but then you have some problems to solve inside of your org, and do not focus that much on agents, because there are some bigger issues to solve first. But yeah, so that's retrieval is something that the vector databases are going to solve, because the main difference between serving search for users, as we did in the past, and serving search for agents is that agents can express themselves in a natural language-like way, and this is known to be solved better with semantic search, because it can capture the intents of the agent or person forming that query, and it doesn't rely that much on the presence of particular words in a query. So definitely we need some sort of semantic search. What I predict will be the future will be the growth of some advanced techniques related to vector search. For example, multi-vector representations, which are already quite important, because we know there are some disadvantages of dense and sparse vector embeddings if we speak about single vector representations, because they don't capture all the nuances of the input data, and multi-vectors seem to be solving that. However, there are some issues with scaling them properly. So definitely I feel there will be a lot of research done in that space, and Qdrant will be definitely taking care of introducing the outcomes of this research directly into the system, so we can still provide you the best semantic search experience, no matter what is the type of the vectors you use.
Okay, thanks. And now, do you have any questions for me as well?
Yeah, definitely. It's always great to meet our users who successfully implemented semantic search with Qdrant. And actually, since I'm not a regular user of GoodData platform, I would really love to know where exactly your users can see the use of semantic search. How does it help them to be more effective in their day-to-day work.
Yeah. So, like to just quickly onboard our listeners. So GoodData is basically an analytics platform, or business intelligence is the legacy word for that. So we allow our customers to basically analyze their data. But with the AI, actually, the paradigm is changing quite rapidly. So instead of static dashboards, we actually envision that in the future, users will be basically talking with data in many ways. And we are like constantly migrating the standard GoodData experience into this vision. So currently, what we provide in all regions in production to all our customers is the semantic search itself, actually. And you would be surprised how valuable actually it may be for the customers who have like thousands of dashboards, thousands of visualizations, many metrics. And it's actually very hard to orient like itself in such a large solution. And obviously, like full text search is good, but it's not good enough if you have so many objects and they are quite similar and you don't know. And it's actually especially complicated for new users who need some kind of onboarding, and actually nobody knows, and you need to find the right person to find the right dashboard. So in this case, similarity search, which is under the hood, powered by Qdrant, is the right solution for these users, and it helps a lot. And the second like place when we somehow utilize a semantic search is our AI chatbot, which is embedded into all like traditional BI applications, but it can also be embedded programmatically into applications of our customers. Or you can basically just integrate with our APIs or use our SDKs. And the AI chatbot is basically a natural language query interface for the end users. So instead of like going through a complex dashboard, you can ask business questions with natural language, and we can like detect your intent, and then we can decide, for instance, to search in the content or to just respond with some natural language response about your business solution. Or we can even like analyze the data under the hood and provide visualizations with some explanations. And like the first version actually didn't contain any semantic search. So we basically took the definition of the whole analytical solution. We send it as a context to LLM. And you can imagine like how reliable it was and how scalable it was. Yeah. So to go to GA, to production, we realized that this is like not the solution we can deliver. So we introduce a RAG architecture in between with Qdrant as a vector database. And we basically need to like vectorize the content of the semantic layer near to real time. So once it's changed by end users in traditional application, it must be available for semantic search and AI chatbot almost immediately. And then when user asks a question, we apply the similarity search. We extract only a relevant part of the semantic layer and send it to LLM. So that's, and actually we do multiple like semantic search hops in this more complex use case because first we need to like put some context to intent recognition part of the platform. And then we again need to apply some similarity search when we decide which part of the semantic layer is relevant. And actually question can contain different types of keywords, so we need to apply different types of similarity searches. And that's pretty much it, like at least for now.
Yeah, but that still sounds like a very complex setup in terms of ritual augmented generation. That's actually how things should be solved, I believe. I saw so many people who were just trying to use dense embeddings directly, but there are so many ways in which you can improve the quality of the outcomes, like intent recognition, because definitely serving different kinds of queries definitely makes a lot of sense to me. So I hope you will agree that RAG is not dead, and I'm also quite curious about how technically implemented that, because I believe you might be also dealing with multilingual data. So did you explore the field of the available embedding models, and how you did that? What are the embedding models you use right now?
Yeah. So in the first version, we actually utilized OpenAI, like the SaaS, to quickly deliver a POC. But in the production version, this may not be the case, obviously. So we experimented with many small language models, and finally we ended up with a paraphrase multilingual mini LM model because it is multilingual, which is actually very important for our customers because we have very large customers who are, for instance, from Brazil. And so they insist on Brazilian Portuguese language. We have a lot of customers in Germany and they insist on German language. So the very small and very efficient small language models are great, like for latency, for performance. But when you need to support multiple languages in a very efficient way, it must be precise, must be accurate. Then you need this multilingual language model. And then because it's still not accurate enough, actually, so we decided to like evaluate other like options we have on top of a standard similarity search. And finally, my colleague, I'm not like subject matter expert, but my colleague decided to go with a cross encoder, which is called M-Marco M-Mini LM model. And he decided to go with that especially because how efficient it is, because like resource consumption matters in our case, but also because how accurate it is and because it supports, again, like multiple languages.
Yeah, that makes a lot of sense. I'm really glad to hear that you not only optimize the query part, I mean, you do this intent recognition, but also the output side when you also rerank the outputs of this fast yet inaccurate retrievers, which makes a lot of sense. If I could also comment on choosing the right model, OpenAI is quite commonly the default tool to use. However, I couldn't really find if they really support multiple languages at the same time. Like they do not officially say that anywhere. So English is the only supported language. However, when I worked with some other languages, I could still see it works to some extent. However, it's not officially supported. So
Yeah.
so in very
Yeah.
specific domains, it may just start to struggle because of that.
Yeah, but actually this wasn't the main reason. The main reason was like the latency because you need to communicate with OpenAI Cloud and also the dependency of the vendor. Like we understand that we need to be dependent like on other vendors in the area of large language models because we are not that big company to operate our own. But in the area of like creation of the embeddings where performance matters, latency matters. So here we can do everything in-house and we want very low latency actually because the similarity search is exposed like directly to the end users. So they expect the UX when you type and after few letters, actually the similarity search returns results like instantly. And in that case, you can't depend on OpenAI. And I am not talking about their outages even, yeah?
Yeah. Yeah, also remember like that hasn't happened to the embedding models yet, but I remember they just decided not to continue with some of their models. And especially if you work with embeddings, if you created like millions or billions of embeddings and they then decide to not continue with a particular model, deprecate it, and eventually remove it, then you are left with billions of vectors that you can't really use anymore. So that makes a lot of sense. Also, I'm always advocating for using the smallest and open source models whenever it's possible. So that makes a lot of sense. Also, it makes it easier to fine tune them if you realize at some point that the fine tuning may help you to boost the quality. So yeah, we are really speaking about a very mature setup. I'm really happy to hear that our users are doing that in so advanced way. I'm also curious about the scale you are operating with, because I believe you might be dealing with billions of vectors already, or maybe just hundreds of millions even. But that also means that you could possibly use some of the optimizations we have in Quadrant, like quantization. Did you happen to use them?
Yeah, so like not billions in our case. We went GA like 2 months ago, 2 months ago. So it's still quite new feature for our customers. But some of them already onboarded. We have many complaints actually, and we are fixing bugs. But in our case, like semantic layer, typical semantic layer consists of like thousands, maybe tens of thousands of objects per customer. Um, because we are talking about artifacts, analytical artifacts, yeah. And so the volume actually is not that large now, yeah. But we are almost sure that actually it will be very large in the future, not only because more customers will be adopting and their semantic layer will be vectorized, but also because we plan to introduce new features, and I'll be talking about them in the end. So we expect like other sources to be vectorized. And so yes, we decided to utilize a multi-tenancy feature. That was actually one of the reasons why we decided to go with Quadrant, because it's supported out of the box, which is great. And multi-tenancy is actually a very strong use case for good data as well. Yeah, our typical customer is, for instance, MasterCard, and they like expose our analytics to their customers, like tens of thousands of banks, and you need to isolate their workloads. Yeah? So yes, we create a multi-tenancy index, and it's very valuable. So we can basically isolate the workloads, and we can rely on the performance for a particular customer. Yeah. And the quantization, yes, well, let me be honest. Yeah, I set some quantization config which was recommended in the documentation. It has some positive impact, but I haven't investigated all features you provide in this area yet. So I suppose that in the future I will utilize even more features you actually provide.
Glad to hear that. Yeah, actually, that makes a lot of sense once the data size just grows. And the good thing is that you can just enable a different quantization method, and it will be just adjusted automatically under the hood, and you will be still interacting the same way. I'm also kind of curious about your future plans, not necessarily in terms of applying semantic search, but generally what are the plans of GoodData for the upcoming months?
Yeah, so where to start? This is actually like highest priority area now in GoodData. So we have many, many plans. Yeah. And not only we have many plans, but our customers are challenging us, and they are bringing new use cases for AI assistants in the analytics. Yeah. So one specific area which actually relate to Quadrant as well is something what is now typically called ontology. Ontology is basically some like graph definition of knowledge for specific like topic, industry, whatever. So we expect our customers are bringing documents, non-structured data, describing their business, describing like what is happening in their company, some workflows, business processes. And we would like to vectorize them and use them as yet another potential context for AI related use cases, for AI assistants. Yeah. And we are thinking about, for instance, how to connect ontology with the semantic layer. Yeah. So like is, for instance, a fact or a metric, does it somehow relate to specific ontology, and how exactly? And is the relation M to N or 1 to N? That's a question for the future. But we are absolutely sure that taking this data into account will improve the accuracy of the solution and reliability. And also it can unlock completely new use cases. So like that's one part, and then the integration. Yeah? So we already in beta, we already exposed MCP server, and we are going to implement more and more tools into this MCP server. These tools will be obviously focused on data-driven decisions. And so we expect our customers will integrate our MCP server together with their MCP servers or other like third-party MCP servers. And then they can build either like better user experience, more complex user experience. That's one option, for instance, in Cloud Desktop. Or they can build agents or agentic systems which actually automate some business processes, where somewhere in between they will need our tools from our MCP server for data-driven decisions in the workflow.
Yeah, this whole MCP world is going crazy. We also introduced our MCP server, and we are just surprised how many people really want to combine LLMs so they can work with all these tools around. Yeah, that's definitely a future. Thank you.
Okay. Thank you very much, guys. Unfortunately, the time has slowly run out, and thank you very much for coming and for the insights into the future of AI and data analytics. I'm very sorry for interrupting you, maybe in the future episode, and thank you very much, everyone, for listening. Hope you enjoyed this episode, and keep your eyes peeled for our other upcoming fireside chats.
Yeah,
Take care.
we will actually see each other with Kacper very soon, right? Because we organize a meetup in Prague focused on AI. And we invited Kacper, he agreed, he accepted. So we are looking forward to see you in Prague in September.
Actually, it's going to be on the 16th. So see you guys there.
Yeah.
See you.